Hi, I'm Juha and I'm a hockey player here at USC. I will be going through some physics concepts and examples with you this semester. And remember, just like on the ice, there's no such thing as luck in physics. Just keep your head up and work hard.
International Space Station makes 15.65 revolutions per day around Earth in its orbit. And if you're assuming circular orbit, how high is the satellite above the surface of the Earth? We could start by just expressing the expression for the orbital period, but rather than remembering it, it's always better to know how to derive it. So let's do it again in this context. So we know that because the satellite is on a circular orbit about Earth, or the center of the Earth, we can say that the sum of the masses is, or the sum of the forces, the net force equals m times the radial acceleration v squared divided by r, where this is the r. And in terms of gravity, we have g times mass of the space station times mass of the Earth divided by r squared, and m times v squared over r. And some of the r's cancel, the masses cancel, and we can solve for the velocity to be just g me divided by r. And now the time it takes to complete one orbit, so that's capital T, is the length of the orbit, so that's 2 pi r with the circumference of a circle divided by v. And we get 2 pi r and v from here, g me divided by r, and by rearranging this square root, we get the familiar r third divided by g me. Now, what is t? We know that the station makes 15.65 revolutions per day. So the time of one orbit is 1/16 of a day, which is, and day is 86,400 seconds. We divide that by 15.65, and we get orbital period 5,520. Let's have some decimals here as well, 0.77 seconds. And once we have that, we can use our expression and solve for the radius of the orbit. So first of all, we raised everything to the second power to get rid of the square root. So t squared divided by that squared, so 4 pi squared is r to the third g me. And solve for r. So r is going to be the third root of t squared times g times mass of the Earth divided by 4 pi squared. And if we put the numbers in, so t is 5,520.77 seconds squared, not 30 squared, times gravitational constant. We probably remember this by now. The units as well, and the mass of the Earth is 6 times 10 to the 24 kg, whole thing divided by 4 pi squared. And what do we get? So let's take the units first. So we have third power of second squared, that's Newton, Newton is kg, m, s squared times meter squared, kg squared times kg. So we have 1 kg there, 1 kg there, 2 there, those cancel, seconds cancel, so we have meters to the third power, and we take third root, so we get meters. Excellent. And the magnitude is about 6,761 kilometers. But now remember, this is just the radius of the from the center of the Earth, and if Earth is somewhere here, we need to subtract the radius of the Earth to get the altitude. So altitude would be radius times the radius of Earth. So 6761 kilometers minus mean radius of Earth 6,378 kilometers. Depending on the source, that's what we usually use. And we get about 382 kilometers for the altitude of the orbit. So about 400 kilometers.